Hello, this is section 2.2. So this is more on functions, but now we're going to be sketching functions. So let's look at this first one. We want to sketch this graph by making a table first. So it's negative x squared. So let's plug in these values into our function. So the first one is f of 0, which would be negative 0 squared, which is 0. The next one would be plus or minus 4. Notice they group the plus and the minus together because it doesn't matter when you square a number, it's going to be positive. So this would become positive 16, but then you got that negative, so that's negative 16. And then the next one's going to be the same, plus or minus 3, negative plus or minus 3 squared. That's going to be 9, but then the negative on the outside makes it negative 9. Similarly, this would be negative 4, this would be negative 1. So to sketch this, it's going to look like this. 1, 2, 3, 4. 1, 2, 3, 4. This is going to go all the way up to down to negative 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 0, 0 is one ordered pair. 0, comma, 0. The next one would be plus or minus 4, comma, negative 16. So positive 4, negative 16. Negative 4, negative 16. Then the next one would be plus minus 3, comma, negative 9. So positive 3, negative 9. Let's see, negative 9 is 1, 2. Well, that's kind of hard to see. So it's about right here somewhere. Same thing. And then plus or minus negative 2. Plus minus 2, negative 4 would be about right there. Right there. And plus minus 1, plus minus 1, negative 1. So there you can see your face-down parabola. Anything that's a quadratic like this will always be a parabola. The next graph looks like it's a piecewise, so we got to graph this. Let's see, this is the way I would go about it. I would just draw a coordinate plane. And there's only two pieces to this function. You're only looking at when x is greater than or equal to 0, and when less than or equal to 0, or when it's greater than or equal to 0. Let's focus on when it's less than or equal to 0. So notice that it's just x. So x looks like this. This is your x. If you were to graph it, it's going to go right through the origin, and it's going to be a line with slope 1. But it's only going to be defined when x is less than or equal to 0. So starting from here down to here is where it's defined. So 0, 0, negative 1, negative 1, negative 2, negative 2, so on and so on. All right. So we took care of the top one. Now we got to take care of the bottom one. And that's when x is greater than 1. Greater than 0. So for example, 1. When x is 1, that's going to be 8. So when x is 1, you have 8. So I'm going to have to extend this up a little further. 4, 5, 6, 7, 8. So when x is 1, it's 8. When x is 2, 2 plus 7 is 9. It's going to be way up here. When x is 3, 3 plus 7 is 10, so it's going to be up here. So as you can see, it's just a linear function that keeps increasing by slope 1. But you do want to plug in 0, even though it's not defined at 0. You just want to see where it's going to be if it were defined there. So if you plug in 0, you're going to get 7. So 1, 2, 3, 4, 5, 6, 7. The graph would have been here, but since it's not defined at 0, you just want to put an open circle there. So open circle at 7, and there it is. So here's your piecewise function. They're both linear functions. This one has a y-intercept of 0. This one has a y-intercept of 7. However, it's not defined at 0 because it's just greater than. It doesn't have the equal sign, so you have to put an open circle. For this one, it is defined, so I would put a closed circle there. And that's how you graph that piecewise function. Here's another piecewise function. This time they give you the graph, and we need to define each piece. So when x is less than or equal to -3, that would be this piece right here. So as you can see, it's just a constant, and the constant is at -3. So it's just whenever you have a horizontal line, it's just going to be that constant number wherever it goes through. This one goes through -3. We can also do this one here. That's also a constant because it's a horizontal line, and that would be +3. So that's when x is greater than 3. That's this one. So that would be +3. The one that has a slope would be in between, which is the one in the middle. So as you can see, the y-intercept is 1, and the slope is 1. Up 1 over 1, up 1 over 1, up 1 over 1. So if you think of y equals mx plus b, the y-intercept is 0 because it goes through 0. Your slope is 1 because the rise over the run is 1 over 1. So that's just slope 1. So your final line is just y equals x. That does it. Using the vertical line test to determine if the curve is a graph of a function, well, you just want to draw a vertical line anywhere you can. And if you have at most one point of intersection, it is a function. So at most one point of intersection means it is a function. If it intersects twice or more than once, then it's not a function. In this case, no matter where you draw the vertical line, it will always intersect just one time. So this is a function. All right, this next one, same directions, but this time you're not using a vertical line test because you're not really graphing. The way to determine whether this is a function or not is you want to solve for y. So let's solve for y. Y squared equals 6 minus x. Then you want to take the square root to get rid of the square. However, when you take the square root of an equation, you always get plus minus. All right, so that plus minus is because of we're taking a square root. And that means for every input, there are potentially 2 outputs. So take, for example, let's say x was 2, for example. Then y would be square root of 4 plus or minus the square root of 4, which is plus or minus 2. So there would be potentially two outputs for the same input. For the input of 2, you have 2 different outputs. That means it's not a function. So, not a function. So, general rule of thumb, you just have to look at the exponent of the y. If it's even, it's not a function. If it's odd, it is a function. Because imagine this were a 3, you would be taking the cube root, and cube rooting an equation does not introduce a plus minus. Only taking an even root will introduce plus minus. So an odd root does not introduce plus minus, so therefore, in this case, it's not a function, but if it were odd, it would be a function. This is the last problem. It says West Side Energy charges its electric customer a base rate of $6 per month, plus 14 cents per kilowatt per hour. For the first 300 kilowatts used. And so for the very first 300 kilowatts used, they're going to charge you $6 plus 14 cents for every kilowatt per hour. Whereas after any usage over 300, they're just going to start charging you 9 cents per kilowatt hour. So for this bottom one, they're going to just charge you 9 cents. But for this top one, they're going to charge you the flat rate of $6 plus the 14 cents per kilowatt hour. So this would be $6 plus 14 times every times x, because x is they're telling you to suppose that a customer uses X kilowatt hours of electricity in 1 month. So you just have to be careful because this represents dollars, this represents cents. So you need to put a 0.14 to make this turn this into cents because this is dollars. So this would be your formula for between 0 and 300 kilowatt hours. So 6 plus 0.14x. And for the bottom, it's just 9 cents per every kilowatt hour. So that's just going to be 0.09x. All right, so that's the difference between those two functions. This one's a flat rate of $6 plus the additional 14 cents for every kilowatt hour. Whereas over here, any usage over 300 kilowatt hours is going to be 9 cents per kilowatt hour. Then they want us to graph this. So let's take a look at the graph. Coordinate plane once again. All right, so let's see. We'll go by 100s because this is going to be a little challenging to graph, but WebAssign will provide you with the graph. So the way it's going to be set up will be much easier than trying to do it the way I'm going to be doing it here. All right, so let's focus between 0 and 300 first. So 100, 200, 300. All right, so between here to here, we have this function. It looks like our y-intercept is 6. All right, so 6 would be our y-intercept. So I'm going to go 1, 2, 3, 4, 5, 6. So we start at 6. That's our y-intercept. And then our slope, you can rewrite your slope if you'd like as 14 over 100 because that's the same thing as 0.14. And now you have a rise over the run. Rise, run. All right, so you're going to go up 14 units. So imagine going up 14. That'll take you to 20. And then you're going to go over 100. So 14, that's why I mentioned it's a little hard to graph here because of the scaling. But let's say 20 was up here. That means you're going to go up 14. 14 plus 6 is 20. Then you're going to go over 100, and that's where your point would be. And since this is defined between 0 and 300, it's going to just continue this line until you get to 300. Closed circle. At 300, you need a closed circle. So notice it's a closed circle, closed circle. So that's your graph there. And then here, at 300, you want to plug in 300 even though it's not defined. So 300 times 0.09 is 27. So here you would go to 27, which is somewhere over here probably, open circle. We'll say 27 is here. So at 27, you want an open circle. All right, that's at 300. And open circle because it's not equal there. And then same thing, that's the same thing as 9 over 100 slope. So you'll go up 9 over 100. All right, so let's say 27 plus 9 is 36. Let's say 36 is right there. And then you're going to go up to 36 over 100. And that's what your line would look like. All right, so that would be the graph of the piecewise function. And that